Alright, we're going to talk about similar triangles today. For polygons to be similar, two things have to be true. Corresponding angles have to be congruent, and corresponding sides have to be proportional. However, if you don't know all the measures of all the sides and angles, there's still a way to tell sometimes that triangles are similar to each other with less information. There are three ways we're going to talk about. One way is called angle-angle similarity. So we write it just AA similarity. That means angle-angle similarity. And that means that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So notice in the picture right here, I got this pair of angles marked congruent and this pair of angles marked congruent. So if I know that those two pairs of angles are congruent, then that's enough information for me to know that these two triangles have to be similar. So therefore I'll know that the third pair of angles are congruent, and I'll know that all the corresponding sides are proportional. Alright, can these triangles be proven similar by angle-angle similarity? And if so, we want to write a similarity statement saying that they're similar. So when I look at right here, I see these angles have been marked congruent, and these angles are both marked as right angles, so they're both 90 degrees, so those are going to be congruent as well. So yes, we can prove that these triangles are these triangles are similar by angle-angle similarity. So when we write a similarity statement, we can name the first triangle in any order we want. So this triangle, I have three letters, A, C, and E, and I can put those in any order I want. I'm just going to say triangle ACE. That triangle is similar to. Now when I write the name of the other triangle, I have to make sure it's in corresponding order. So if A goes first, which angle would be congruent to angle A? That would be angle D. So D would have to go first. Angle C is congruent to angle B, so because C went second, B goes second. And then angle E in this triangle is congruent to angle E in this triangle. That point is being shared by both triangles, so E corresponds with E. Alright, let's check the next one. On this one, none of the angles have been marked congruent, but we could figure out that some of them are congruent. One way, you could see a pair of vertical angles right here. Angle JHK and angle GHF are congruent because they're vertical angles. And then notice the arrows marking these two lines parallel, and then we have other lines intersecting those two, so we have transversals. So right here, parallel lines, transversal. Here is a pair of alternate interior angles. They have to be congruent. Technically that's enough right there, but also parallel lines, we got another transversal, we have another pair of alternate interior angles that are going to be congruent. So I can actually figure out that all three pairs of corresponding angles are congruent, which is more than enough to say that these triangles are similar by angle-angle similarity. So yes, we can say they're similar. So now let's write our similarity statement. So I'm going to name this first triangle, put the three letters in any order I want. JKH, triangle JKH is similar to triangle, and then just make sure that that second triangle goes in corresponding order. So I put J first, it corresponds with F. Those angles are marked congruent. So because J went first, F needs to go first. K corresponds with G, because those are congruent. So since K went second, G goes second. And then H is a vertex that's shared by both triangles, and those two angles are congruent, so H corresponds with H. Alright, you can use angle-angle similarity to find missing measurements in triangles. So let's try that real quick. Given that line segment AB is parallel to line segment CD, the distance from A to B is 4, the distance from A to E is 3x plus 1, the distance from C to D is 8, and the distance from E to D is x plus 12. We want to find the distance from A to E and the distance from D to E. Alright, well, A to E and D to E are both labeled with expressions right now, So before we could figure out what those two sides are, we have to know what x is. Now, technically, we have not been told that these triangles are similar either yet, but just like the problem we just did a moment ago, we have a pair of vertical angles. We've got parallel lines with transversals that create alternate interior angles that are congruent. Parallel line, transversal. So again, I can figure out that these angles are congruent. So therefore, by angle-angle similarity, I know I have similar triangles. Now, these pieces are all labeling sides, and we know in similar triangles that the sides are proportional. So anytime I know I have similar triangles and I'm trying to find missing sides, I have to set up a proportion because I know the sides are proportional. So the distance from A to B corresponds with the distance from C to D. And I know that because it's going from these angles that are congruent to these angles that are congruent. So I know that's corresponding sides. So I will put those in the same ratio. Then because I put the 4 on top, and the 4 comes from this triangle, then all the sides from this triangle need to go on top when I'm continuing my proportion. So the 3x plus 1 is going to go on top in the numerator. And 3x plus 1 is going from this angle to this angle, so I want to see which side goes from between those same corresponding angles on the other triangle. So right here, going from that angle to that angle, this would be its corresponding side. The x plus 12 would correspond with the 3x plus 1. If it helps, you can write yourself a similarity statement first, and then you can use your similarity statement to look at it to see which sides are corresponding. So here's our proportion, and we want to cross multiply and solve. When I do that, when I multiply this way, 8 needs to multiply times all of 3x plus 1, so I have to distribute to make that happen. So 8 times 3x is 24x, and 8 times 1 is 8. So there's that cross product. Then when I multiply the other direction, I have 4 times x plus 12. And again, that 4 needs to multiply times all of x plus 12. So to make that happen, again, I have to distribute. 4 times x and 4 times 12. And from here, I'm just solving an equation. Can't have x on both sides, so I'm going to get rid of one of them. I always get rid of the smallest. So 24 minus 4 is 20 x's. That's gone. I just bring down the 48. I want to get x all by itself, so I'm going to get rid of the 8. It was being added, so we'll do the opposite and subtract it. Now I'm just going to rewrite my equation over here where I got a little bit more room. So x is being multiplied by 20, so I divide by 20. And 40 divided by 20 is 2. So now we're not done because the directions did not ask us to solve for x. They asked us to find the distance from A to E and the distance from D to E. So for the distance from A to E, we had an expression of 3x plus 1. Now that I know what x is, I can substitute that number in. 3 times 2 is 6. 6 plus 1 is 7. So the distance from A to E is 7. And then we just do the same process with the distance from D to E. We have an expression of x plus 12. So if I know x is 2, I can substitute 2 in here. And 2 plus 12 is 14. So the distance from D to E is 14. Alright, so we've talked about angle-angle as one way to prove that triangles are similar. A second way to show that triangles are similar, written like this, is side, angle, side similarity. Each S stands for the word side, each A stands for the word angle. If two triangles, or excuse me, in two triangles, if two pairs of corresponding sides are proportional and the included corresponding angles are congruent, then the triangles are similar. Okay, adding in the sides is one transition that some kids have difficulty with because the sides are not going to be congruent, they're just going to be proportional. So we're just checking for them to be proportional. Alright, so notice over here in the example, you do have a pair of congruent angles. And the sides are going to be proportional because if I match this up with the 2 right here, because those correspond, and I match this side up with this side because those correspond, those ratios would come out equal to each other because this is already reduced, 1/2, and 2 over 4 can be reduced to 1/2. So those ratios are equal, meaning the sides are proportional. So I have 2 pairs of proportional sides, and I have the included angles are congruent, the angles that are between those sides that we know are proportional. Alright, so in example 3, can the two triangles be proven similar by side angle side? And if so, write a similarity statement. Well, the quickest thing you can see is that these two angles are congruent. So that part's easy. So we just have to check and see, are the sides proportional? So I'm going to set up the proportion. The 4 should correspond with the 6, and the 6 right here should correspond with the 9. And we just want to see, are those equal to each other? Because if they are, then we have 2 pairs of proportional sides, and therefore, by side angle side, we would know that these triangles are similar. Well, 4 and 6 are both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 6 and 9 are both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And so notice that both of these are equal to each other because they're both equal to 2/3. So we have 2 pairs of proportional sides. We have the included angles are congruent. So by side angle side, yes, I know that these triangles are similar to each other. And I can write a similarity statement. So I can name this triangle in any order I want. I'm going to call it triangle MNL. And that's going to be congruent, or excuse me, not congruent, similar to triangle. And so because I put M first, I have to put P first because those would correspond. N corresponds with R, so since N went second, R goes second. And then L corresponds with Q. So there's our statement saying that these two triangles are similar to each other. Okay, and there's one more way to prove that triangles are similar. And the S's stand for the same thing they did on the previous one, so this is side, side, side. Side, side, side similarity. If all 3 pairs of corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So notice over here, these would be proportional because each one of these sides is exactly 3 times the length of this one. 1 to 3, 3 to 9, 2 to 6. I could actually set those up and reduce them all to 1 over 3 or 3 over 1, depending on which one I put on top. So the sides are all proportional, so these 2 triangles are similar based on side, side, side similarity. So looking at example 4, are these triangles below similar by side, side, side? And if so, write a similarity statement. So let's set up a proportion. And if we're not exactly sure what should correspond with what, right now these pictures are turned the proper way for us where it's easy to see what corresponds with what. But if you're not sure, just remember that the smallest side from this triangle has to correspond with the smallest side from this triangle if they're going to be similar. The largest side has to correspond with the larger side and so forth. So smallest side over here is 3. It's going to correspond with the smallest side over here, which is 9. Okay, the medium sized one would be 4, and the medium sized one here would be 12. I'm making sure all of these go on the top and making sure all of these go on the bottom. 5 is the largest side from this triangle, and 15 is the largest side from this triangle. And I want to check and see if all these ratios are equal, and therefore the sides are proportional, and therefore the triangles will be similar. So 3 over 9 reduces to 1/3 because both of those are divisible by 3. 4 over 12, both of these are divisible by 4. 12 divided by 4 is 3. And both of these are divisible by 5. 15 divided by 5 is 3. So they all reduce to 1/3, so these are proportional sides. And therefore, by side, side, side similarity, these triangles are similar to each other. So because of that, we can write a similarity statement. So I'm going to call this triangle STU. I can put those in any order I want. But once I decide the order of these, that determines what order these have to go in. They got to go in corresponding order. S corresponds with X. T corresponds with W, and U corresponds with V. Alright, so down here, are the 2 triangles similar, and if so, state how. So we've learned 3 ways that they could possibly be similar. Angle, angle, side, angle, side, and side, side, side. So we're looking for one of those 3 possible ways to show that the triangles are similar. So right here, let's see what we have. I can see that these angles are congruent. I don't see any other angles or sides marked. Now, some people might not even see the 2 triangles happening. We got this small triangle right here, and then we got the larger triangle that has the small one inside of it. Notice that they are sharing angle x. So that angle is the same angle for both triangles. So reflexive property, that's a pair of congruent angles. So we now have two pairs of congruent angles. So yes, we know these triangles are similar by angle similarity. Okay, we look at the next one. We got a very similar situation happening where we got the big triangle and then we have the small triangle inside of the bigger triangle. So just like the last one, they're sharing an angle here at the top. Angle L is the same angle for both triangles. And then I can check and see if these sides are proportional because they gave me some side lengths. Remember, for the big triangle, this side would be 6 plus 3, it would be 9. And over here for the big triangle, this side would be 10 plus 5, 15. So make sure you're using those for the big triangle. So when we set up our proportion, the small triangle has a side length of 6. The corresponding side for the big triangle would be 9. Over here, the small triangle has a side length of 10. And the big triangle has a side length of 15. And we want to check and see if those ratios come out equal. So we'll know that the sides are proportional. So 6 over 9. Both of those are divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 10 and 15 are both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So you see that the sides are proportional. So we have two pairs of proportional sides, and we have the included angles, the angles between those sides that are congruent. So I do know that these triangles are similar by side angle side similarity. Okay, over here, I've been given all the sides. So I'm thinking if I'm going to prove that these triangles are similar, there's a good chance it's going to be by side, side, side. So I want to compare all the sides. One thing I need to be careful about is on this big triangle, to remember that this side right here is 6 plus 6, which is 12. So now, these have been flipped and turned, so here's a good time to remember that small corresponds with small and big corresponds with big. So from the little triangle, the smallest side would be 3. And from the bigger triangle, the smallest side would be 6. On the little one, the next smallest would be 5. Big triangle, next smallest would be 10. And then the largest side from the little triangle is 6, and the largest side from the big triangle is 12. And I want to see if all these ratios come out equal to each other. So 3 over 6 will reduce to 1/2 because both of those numbers are divisible by 3. 5 and 10 are both divisible by 5, so it also reduces to 1/2. And 6 and 12 are both divisible by 6, so again it reduces to 1/2. So I do have 3 pairs of proportional sides, and so I know the triangles are similar by side, side, side similarity. Alright, so let's try to use this to solve for x, find some missing pieces, solve for y. Alright, so on example 8, we want to solve for x and y and round to the nearest hundredth. So we should see the larger triangle and we should see the smaller triangle in here. Okay, I know that they are sharing angle C. And then I also noticed that these are parallel. So because those are parallel, I know that these corresponding angles are congruent. We got parallel lines, transversal. These are at the same place at those two different intersections. They're corresponding angles. And the same can be set up here. Same parallel lines, but a different transversal. We get another pair of corresponding angles up here. So I have plenty of information to know that these triangles are similar by angle similarity. So now that I know the triangles are similar, I know that all their sides have to be proportional. So I can set up proportions to solve for the sides. Now, for the big triangle, this side is 3 plus 4, which is 7. And for the big triangle, this side would be x plus 3. Now I can't combine those because they're not like terms, so I would just write that expression x plus 3 right there. So now let's set up a proportion to solve for x. If I want to set up a proportion to solve for x, I got to use x. So on the big triangle, I have a side length of x plus 3. And on the little triangle, the side that corresponds with that would just be the 3. then I need a ratio where I have two numbers. I don't want any other variables. So the y and the 8 correspond, but I don't want to include y in the same equation as the x. So I'm going to focus over here. Now because I put x plus 3 on top, that was the side length for the big triangle, I need to put a side length for the big triangle on top again. So I'm going to put the 7 on top. And its corresponding part from the little triangle would be 4. So the 4 goes underneath. So there's the proportion to solve for x. I cross multiply. So right here I have 4 times x plus 3. And I need 4 to multiply times all of x plus 3. So it needs to distribute 4 times x and 4 times 3. And then go in the other direction, I have 3 times 7, which is 21. So I set those cross products equal to each other, and now we just have to solve that equation. So x, I want to get x by itself. 12 is being added, so I do the opposite and subtract it. And then I divide by 4. And we're going to need to round to the nearest hundredth. So I got 9 divided by 4 is 2.25. So we don't actually have to round. It actually comes out. It stops exactly at the hundredths place. So we don't need to round. There's an exact answer of 2.25. Alright, we also need to solve for y. So I'm going to set up a proportion to solve for y. Y corresponds with 8. So I'm going to put those in the same ratio with each other. And then I need another pair of corresponding sides, and I don't want variables. And technically I found x, but if I messed up there, I don't want it to cause my next answer to be wrong as well. So I prefer to use these numbers since they're available. Because I put the y on top, I need a side length from that little triangle to continue to stay on top. So I'm going to use the 4 on top. And the corresponding side length from the big triangle would be 7. So here's my proportion. Y over 8 is equal to 4 over 7. Cross multiply. 7 times y. 8 times 4 is 32. And then I want to solve the equation. So y is being multiplied by 7, so I divide by 7. So we got 32 divided by 7 is approximately 4.57. There's a 1 after that, which is not big enough to round up. Alright, last thing in the notes. Are the two triangles similar? And if so, what is the scale factor? Remember, scale factor is what we multiply the original figure by to get the new figure. So it says the measures of the sides of triangle ABC are 4, 5, and 7, and the measures of triangle XYZ are 16, 28, and 20. Well, they gave us sides. If I want to know if the triangles are similar, I would need to know that all the sides are proportional. So then I could prove the triangles are similar by side, side, side similarity. So I'm going to take all the sides from triangle ABC and put those in the tops of the ratios, in the numerators. And then I'll take all these and put them in the denominator. Now it's very important that we're matching up corresponding parts in each ratio. So remember, small corresponds with small, big corresponds with big. So 4 is the smallest number here, so I need to make sure it's corresponding with the smallest number from this grouping. So that would be the 16. 5 is the next smallest, so the next smallest over here would actually be the 20. And then 7 is the largest from these sides, and 28 is the largest from these sides. So it's very important that we put those in the proper places. If you just wrote these down in their order, then you would get the wrong answer. Alright, we want to reduce and see if these are all equal to each other. 4 and 16 are both divisible by 4, so that would reduce to 1/4. 5 and 20 are both divisible by 5. 7 and 28, both divisible by 7. These all reduce to 1/4. So these sides are all proportional. So by side, side, side similarity, I know that these triangles are similar. So what would be the scale factor? What would I multiply everything from the original figure by to get the side lengths from the new figure? Now remember, what we did a minute ago was we found the ratio of, the similarity ratio. And remember, scale factor is always the reciprocal of that. So if I flip this fraction, I would get 4 over 1 or just 4. Notice if I multiplied all these numbers by 4, I would get these numbers. 4 times 4 is 16. 5 times 4 is 20. 7 times 4 is 28. So the scale factor is equal to 4. Alright, one last time. Triangle PQR has sides 3, 5, and 6. Triangle STU has sides 2, 2.5, and 3. Alright, so again, I'm going to put these across the top in the numerators, and I'll put the sides from the other figure in the denominators underneath them. Small with small and big with big. So 3 is the smallest side, and 2 is the smallest side. 5 is the medium size, 2.5 is the medium size. 6 is the largest, and 3 is the largest. So put those all in the same ratios. Now we just want to simplify those. 3 over 2 is already simplified. It's already reduced. 5 over 2.5 can be reduced to 2. 2.5 goes into 5 exactly 2 times, and 3 goes into 6 2 times. So these are not all equal. They do not all reduce to the same thing. That means the sides are not proportional, and therefore these triangles are not similar. If the sides are not proportional, then the triangles are not similar.